Ionic reaction which occurs when potassium thiocyanate solution is added to a solution of iron 3 nitrate. The product is dark red. But before we look at what happens at the molecular ionic level in this reaction, we need to look at each reactant in detail, starting with aqueous potassium thiocyanate, a clear and colourless liquid. Now imagine we could zoom down to the size of molecules and ions. The potassium and thiocyanate ions occasionally collide, but there is no chemical change. In water, the potassium ions are hydrated with, on average, about 6 water molecules around each ion. The same applies to the thiocyanate ions. The oppositely charged ions only occasionally form an ion pair, so they should be shown as separate ions in the formula representation of this solution. When you see a solution in a test tube, try to imagine the mobile hydrated ions and link this image to the formula representation. The other reactant is aqueous iron 3 nitrate, a clear pale yellow solution. At the molecular ionic level, imagine we can fade out the intervening water molecules. Now you can see the hydrated ions in the background. The more concentrated the solution, the closer the ions are to one another. In the hydrated iron 3 ion, notice how the bonding between the water molecules and iron 3 is stronger than in the other hydrated ions considered so far. For every iron 3 ion in the solution, there are 3 nitrate ions. So this must be shown in the formula representation of the solution. The colour of aqueous solutions containing iron 3 depends on what is bonded to the metal ion, in this case only water molecules. Now that we have studied the 2 reactant solutions, let's see what happens at the molecular ionic level when they're mixed. When a thiocyanate ion collides with a hydrated iron 3 ion, it can displace one of the bonded water molecules, forming a new complex ion. Elsewhere in the solution, a complex ion so formed can lose its thiocyanate ion, with a water molecule taking its place. The reactant and product complexes absorb visible light of different wavelengths, so the color of the solution indicates which complex predominates. The lower ball and stick structure shows how the atoms are connected. Now let's see how the formation of the complex is described at the symbolic level. Notice the formula for the thiocyanate ion is reversed to show that the nitrogen end bonds to the iron. The equation for the dissociation of the complex is simply the reverse of the formation equation. We say the reaction has reached equilibrium when both these reactions are occurring at the same rate. Look for simultaneous formation and dissociation of complex ions. Now you can imagine what a reaction at equilibrium is like, where opposite reactions are occurring, but the overall concentrations of reactants and products remain constant. At equilibrium, iron thiocyanate complex ions continually form and dissociate, but their concentration stays constant, so the solution color doesn't change.